This wonderful session. In this video, we are going to see how to become a best engineer. Let's say we are all engineer working in a product manufacturing company. The company wants to deliver its final product to the customer, and for that, the company requires some open type of boxes to pack those items, manufacturing items. And the company had some stacks of cardboard sheets, and it wants to utilize those cardboard sheets to make those boxes. Okay, so company call all its employees and giving an open problem statement, something like, we are having a cardboard sheet of size 30 centimeter cross 30 centimeter like this, and we need to make a open type of box, and that box should have a maximum volume. Okay, so whoever comes with the better solution, they will be rewarded as well as awarded as a best engineer of the year. Okay, fine. So as we are an engineer, we need to prove ourselves to become as a best engineer, right? Okay, so the first thing is we need to know how to make a box, that means open type of box using this cardboard sheet. Okay, one simple way of doing this is, let's take this box, cardboard sheet, and cut the four corners like this. Cut the four corners like this. Like this. You will be getting. So you will be getting a final card like this, and now folding this four sides, folding this four sides, we can make a open type of box, right? By folding this four sides, we can make a open type of box. Fine. So now we understand how to make a box using this cardboard sheets. Now we need to focus on how to make a maximum volume out of this cardboard sheet. Okay, fine. I believe cutting these corners with a different length, we can make a different sizes of boxes. So different sizes of boxes will have a different volume. So from that we can pick which box is having maximum volume, right? Okay. So let's start this experiment, and I don't want to waste the cardboard sheet. Let's save the nature, and we'll do it on board itself. Okay. So here I have taken 5 different cardboard sheets. Okay, and I am going to cut the cardboard sheet with a different length. Fine. Okay, so let's start cutting with a length of 1 centimeter. 1 centimeter, and here also 1 centimeter. Okay, so if I am cutting this cardboard sheet, like if I am removing this corner, so the cardboard sheet will looks like this. So the cardboard sheet will looks like this. By folding the four sides, we can make a box like this. We can make a box like this, right? Fine. Okay, so our target is to find the volume, right? What is the volume for a box? What is the volume of this box? It is nothing but length into breadth into height, right? Length into breadth into height. So what is the length? So this is going to be length, and this is going to be length, and this is going to be the breadth, and this is going to be the height. Am I right? Okay, now you guys tell me, what is the length of this box? This length of this box is obtained by this one. So this length is nothing but 30 centimeters the total length, and we are cutting 1 centimeter here and 1 centimeter here. So this length is going to be 30 minus 1 minus 1, which is nothing but 28 centimeter. Similarly, to find the breadth, so here it comes. So here also the total length is 30 centimeter, and here we are cutting 1 centimeter here and 1 centimeter here. Again, this is going to be 28 centimeter. So breadth is 28 centimeter, length is 28 centimeter. Now what is the height of this box? So height of this box is nothing but by folding this only we are getting height, right? So what is this height is going to be? This height is nothing but the length we are cutting, which is nothing but 1 centimeter. 1 centimeter. So this is going to be 1 centimeter. This is going to be 28, and this is also going to be 28. 28 centimeter. 28 enter 1 centimeter, which is nothing but 742 centimeter cube. Okay. So let's keep this is a volume 1. Okay. Fine. So so this is with 1 centimeter. So let's start increasing the length of cutting. Okay. So here I am taking 4 centimeter. So 4 centimeter here, 4 centimeter here. Okay. Now if we find the volume of this box, what is going to be the volume? So volume is again L into B into H. So length is formed by this area, this length, and the breadth is formed by this length, and the height is formed by this length. So length is nothing but, so total is 30 centimeter minus 4 centimeter minus 4 centimeter, which is equal to 8 centimeter, and breadth is nothing but, so 30 centimeter minus 4 centimeter minus 4 centimeter. So again 30 minus 8. Height is nothing but the length which we are cutting, that is equal to 4. So this is going to be 22 the whole square into 4, which is nothing but 1936. Okay, 1936 centimeter cube. Fine. Okay. So if we are again if we are increasing, so here 1 4. So next value I am taking 7 centimeter. Let's take 7 centimeter. Okay. So if you take 7 centimeter, volume is equal to L into B into H again. So this is going to be length. The length is equal to 30 minus 7 minus 7, which is nothing but 30 minus 14. This is length, and breadth is also going to be same. So I am putting square here, and height is nothing but 7. Okay. So 30 minus 14 is nothing but 16 whole square into 17. So which is going to be 1792. Okay, fine. And now coming to, now if I am keep on increasing, so 7. So let me take it is equal, take it 12. Okay. So if I am take length of 12, let's take this is V4, which is nothing but 30 minus 12 plus 12, which is equal to 24, the whole square into what? 12, which is equal to 6 square into 12, which is equal to 432 centimeter cube. If I am further increasing the length, what happened? So yeah, I can take a maximum length of 15 centimeter. 15 centimeter here, 15 centimeter here. Okay. So that is the maximum length I can cut. So if I cut it 15 centimeter, what will happen? So the entire sheet is going to be cut into 4 pieces. So the volume formed by is equal to 0. We cannot make any box using that, right? Okay, fine. So to understand these things in a better way, okay, so let me plot all the data in the graph. Okay, so I am taking on graph x-axis, y-axis. In x-axis I am keeping my length, and in y-axis I am keeping a volume V. Okay, fine. So at L is equal to 0, if I am cutting the cardboard sheet with the length of 0, can I make any box? Because we are not cutting anything. Can we make a box? No, right? We cannot make a box without cutting the corners, right? So the volume is going to be 0. Okay, the volume is going to be 0. Okay, now when the length is equal to 1, what is the volume we are having? We are having 742. We are having, let's say I am keeping 742. Fine. Okay, so if the next one is what? 4 centimeter. So 4 centimeter, let me keep it here, 4 centimeter. So 4 centimeter I am seeing 1936. So something like here 1936. Okay, and what is for volume 3, which is equal to 7 centimeter. So 7 centimeter I am getting 1792. Okay, 1792. Very good. Okay, at length is equal to 12 centimeter, if we take length is equal to 12 centimeter, so we will be getting 432, comparatively less, 432. And if we increase to maximum length, which is equal to 15, so we are getting a volume of 0. We are getting a volume of 0. Okay. So if I start connecting all those points, so this is keep on increasing, and after that it start decreasing and comes to 0. Okay, fine. But so if you understand, if you see the graph, as the length increases, the volume also keep on increasing till the point 4, and after that it is keep on decreasing. So can we say that this by cutting the 4 only we are getting a maximum volume? By seeing the graph, can we say that by cutting the box with a length of 4 we can make a maximum volume? But I am not satisfied, because I am just taking a random length and I just found that volume. So I am more interested what happen if I am increasing the length further little bit. Okay, which means a center, we can take a center 4 to 7, which is nothing but 5.5. Okay, if I am cut the cardboard sheet with the length of 5.5, what is my volume? Let's say that is equal to V6. Okay, it is nothing but 30 minus 5.5, 5.5, right? Is equal to 11. So 30 minus 11. Similarly, 30 minus 11, the whole square into 11. This is equal to 19 whole squared into 11. So if you calculate this, you will get 1985.5. Okay, if you plot this 1985.5, it will come almost here, 1985.5. Okay. So now the curve will not go like this, it will go like this. But still I cannot assure this is going to be the maximum volume. This will give the maximum volume. So there are an infinite number of points in between 4 and 7. I cannot put each value and verify which is giving a maximum value, which is giving a maximum value. That is not possible, right? So instead of playing with these numbers, I am going to play with the variables. Okay. So instead of taking this number, I am going to play with a variable. Okay. So for that, what I am going to do is, first of all, I need to find the equation for this curve. How to find out? So this equation is nothing but V is the function of length L, right? Volume is the function of length L. Okay. So instead of cutting at a particular points, let me make it a variable L. Okay, L. Okay. So if I am cutting, this is going to be 30 centimeter. If I am cutting this 30 centimeter with the length L, what is my volume? Just nothing but 30 minus L plus L, 2L. Similarly here also 30 minus 2L square into L. Okay. So 30 minus L, A minus B the whole square is nothing but A square 900 plus 4L square minus 120L into L. So V is nothing but 4L cube. I am rearranging 4L cube minus 120L square plus 900L. So this is the equation for this given curve. Okay. So I have just redrawn the graph as well as the equation. Here I just removed all the points in between. So we are dealing with the variables. I just removed all the points and the corresponding equation I have written. Okay, fine. So I know that as length increases, my volume is keep on increasing at one point. After that it will start decreasing. So this is going to be my maximum volume. So I am representing this as a Vm. Okay, fine. So the corresponding length I am mentioning it as Lm. Let me like a maximum length. Okay, fine. So I am going to find out this Lm only, right? Fine. So to find out this Lm, I am going to take a help of a differential equation. Okay, so what differential equation telling here is, whenever you have a curve like this and like this, so this point is called a maximum point and this point is called a minimum point. Okay, so at those points your rate of change of this curves is going to be 0. This is what differential calculus is saying. So I will tell you in a simple way. So let's assume you are throwing a ball. Okay, let's assume you are throwing a ball and the ball will definitely go like this, and after some point it will come down to the earth, right? Okay, so here rate of change is nothing but the speed of the ball. In this case it is speed of the ball. So if you plot the speed of the ball, so initially you will be throwing a ball with the full force, right? So that time your speed is going to be maximum, which means 0. Okay, so your speed is going to be maximum. As it is keep on increasing, it will lose that speed. Okay, it will lose that speed. At one point what happened, it lose that speed completely. At one point it lose that speed completely. So at that point it cannot move up further. The ball cannot move up further. It has to come down to the earth. Okay, so at that point that gravitational force will force that ball to come down to earth. So you will be seeing some negative speed. Okay, fine. So the same curve is, we are also getting the same curve. So and the same way I am just redraw, and the same way I got the derivative curve for this even function, just nothing but dv by dl. Okay, fine. So to find out the point lm, this is my lm. Okay, so to find out the point lm, I am going to differentiate this curve, differentiate this equation with respect to L and make it to 0. Okay, so then I am going to get this Lm, right? Okay, so how can I do that? So let's take this equation and do dv by dl, just nothing but differentiation, simple differentiation. So 4 L cube means, so 4 into 3 12 L square minus 240 L plus 900, and as I said, we need to equate to 0. By equating to 0, so we need to solve this equation. Can we take 12 outside, because 12 is common in all the cases? So if I am taking 12 outside, so I will be getting L square minus 20L plus, so this is going to be 75 equal to 0. Okay, so now if I find the factor for this is going to be L minus 5 and L minus 15 is equal to 0. So L is equal to 5 and L is equal to 15. Okay, fine. So we are getting a 2 value for L. Okay, so if you are cutting the box with the length of 15 centimeter, we know that we will not get a box, we will get a 4 cardboard sheets only, right? Yeah, so this will not give a maximum volume of box. So but if we cut the box with the length of 5 centimeter, definitely we will get a maximum volume to box. Okay, so this point is going to be Lm is equal to 5 centimeter. Okay, so I know your curiosity to find the volume of the box, so let's do it. So volume of the box is nothing but V is equal to L into B into H. You can use either this equation or this equation. Okay, so last case, if we cut the L is equal to 5 means, so in total of 30 centimeter, 5 centimeter here, 5 centimeter here we used to cut. So length is going to be 30 minus 10. Similarly breadth also 30 minus 10, and height is going to be the length 5 centimeter. Okay, so 20 into 20 into 5 is nothing but 2000 centimeter cube. So with the given box of size 15 centimeter and 15 centimeter, we can make a maximum volume of 2000 centimeter only. We cannot make a box more than this 2000 centimeter. This is the maximum volume. We cannot, no one can give a maximum volume more than this. Okay, so definitely we will get a reward as well as award of the best engineer of the year. Okay, thank you. Fine. Now you might have one more doubt. Sir, you told that whenever there is a curve like this and that like this, at this point and this point only, we will be getting rate of change is equal to 0. But here at LM is equal to 5 centimeter, I am seeing the curve like this. But LM is equal to 15 centimeter, I am not seeing any curve like this. I am not seeing any curve like this, right? Because we are limited our curve only for our operation. Because here the possible length, the possible cutting length is 0 to 15 centimeter only. We are not focusing above 15 centimeter. But this equation is valid for all the value of L's. Okay, all the value of L. If you are plotting this this equation for all value of x, which means minus infinity to plus infinity, the graph will be looks like this. The graph will looks like this. The graph will looks like this. Okay. So now you can see here also there is a one more curve coming like this. So this is maximum, means this is going to be minimum. Okay. So that's why. So if you are plotting the rate of change for this curve, so this is going to be something like here it has to come to 0. So it is keep on increasing, means one point it has to go like this and it has to reach 0 value. Okay. So this point is called 15. So this point also, like we can call it as a minimum point. Okay. This is the concept of maxima minima. Okay. So hope you enjoyed this session, and will you see in the next session. Thank you all.